Hello, everyone. Thanks for joining us tonight. City Architecture Forum, the latest of a number of events we've had which showcase existing and coming buildings. And this is very definitely a coming building in the city. So we're here to talk about 8 Bishopsgate, which is on site at the moment. As I said earlier, in fact, we all went to the site today. I was just standing outside, these two are inside. But it's, I think, up to about level 24, isn't it? So it's coming up very fast. So tonight we've got speaking Oliver Tyler of WilkinsonEyre, who's the architect of the scheme, and Jeremy Edwards, the director of Arup, head of London property, who's the principal engineer on the scheme and been working on the project for a while. No doubt I'll say that. So, and just in terms of questions and answers, if you want to ask any questions, please put them in the Q&A button and I'll pick them up and we'll deal with the questions, I think, at the end. I think for about, these guys are going to speak for about half an hour and then we'll have a Q&A session after that. So without further ado, I'll pass you over to them.
Hi, good evening. My name's Oliver Tyler. As David said, I am a director at WilkinsonEyre and I have been the project lead on this project since we did the competition back in 2013. Jeremy.
Hi, I'm Jeremy Edwards, project engineer for Arup. I'm just about trying to work out how to change the next slide. For some reason, the presentation's just crashed at a rather inopportune moment, Ollie. So if you could filibuster for a short period while I try and correct the presentation.
Okay, so I'll start as we have half an hour. So the site sits at the junction of Leadenhall and Bishopsgate. It was made up of 2 existing buildings, 6 to 8 Bishopsgate and 150 Leadenhall, which were late 60s, early 70s, quite fine GMW buildings, but had very much reached their end of their life for sort of useful sort of commercial reworking. And so our brief and the competition brief was to look at the development potential of the site. Is this on automatic movement now, Jeremy? Or are you? So the context is very interesting because we're very much on the southwest corner of the eastern cluster, the area designated in the city for tall buildings. And directly to our south and to our west, we have conservation areas. So we're very much the edge of the tall buildings cluster. And as a result of that, enjoy fantastic views to the south and to the west. And when we started looking at the scheme back in 2013, it was a competition run by Stanhope for Mitsubishi, who were a client we'd worked with previously on 8 Finsbury Circus. And in fact, last time I talked to the City Architecture Forum, it was about that building and introducing this. So the key issue for us was looking at the constraints for the site, and the constraints whilst informed by the footprint of the site and also the view management framework. The key issue, and certainly for the city, was this view down Fleet Street, which is the view looking at our site in the backdrop behind St Paul's. And there was a lot of pressure in the constraints here not to be stepping into the sky past the southern edge, the angled face of the Leadenhall building. Next. So on the right, you'll see that there's a development envelope, and this envelope was very much informed by the silhouette of the Leadenhall building. So it was about trying to look at an appropriate form. And at that time, we had the Helter Skelter scheme, the pinnacle on the 22 Bishopsgate site, which was again a tapered form as well. So we were very keen that, we probably looked to find something that was more distinct than those 2 buildings. Next. So we developed a concept. We looked at sort of tapered forms to begin with and sort of more shaped forms. But we developed a concept of looking at the different sort of datums that occur around the city, and rather than have one single sort of extruded form, we developed this concept for a series of stacked blocks and look at for the potential through those blocks to create terraces and activity on each of those ledges. And to sort of express the architecture, we looked at this idea of actually trying to cantilever each block out over each and give each a sort of distinct identity. Next. So these very early sort of concept drawings were just sort of showing these ideas of how this sort of series of stacked blocks would fit within that constraint of the angled face of the Leadenhall building. Next. So this sort of slide is quite interesting. We find looking back at how the context changed, but also the approach to the design. So in January 2014, our competition scheme, much more sculpted, but had the idea of a lower building sitting on the junction that dealt with the sort of context of the lower city buildings around the junction, and then a taller element that it was co-joined with. But as the city were changing, the planning department was changing. It was the time that Peter Rees was leaving and Gwyn Richards taking over. They were interested in us looking at much more rectilinear forms, and how this helped drive us towards the stacked block concept. Next. And this shows the sort of, as we do with a lot of what we do, is a lot of testing through 3D models before sort of arriving at a form that you know, we look to move forwards with. Next. So the concept was taken forwards to actually give each block a slightly different identity. It's the same basic cladding system throughout. We've adopted a CCF, a closed cavity double skin facade. And then around the junction, we have a stone clad building that looks to respond more to the context there. So as we move up through the height of the building, the cladding module opens up. We've put all the diagonal bracing, and Jeremy will talk about this, we've contained within one of the blocks. And so the module of the cladding opens up and becomes more open as you move up through the height of the building. And all the diagonal elements are contained within one element, the mid block. And then we've also looked to sort of a play with the texture of the surface with projecting brise-soleil screens, vertical screening on the mid block as well. So it becomes much more open on the upper block, and then we have the pavilion at the top. Now, for us, we secured planning consent for a 40-story building in 2015, and the building, as is typical, we find with a lot of city buildings, go into a sort of lull period while the client decides the appropriate time to move forwards. And in that time, the context around the site changed significantly. So 22 Bishopsgate moved forward from the Pinnacle scheme to 22 Bishopsgate 62-story scheme. And also One Leadenhall, the site directly to our south, came forward with a scheme of 40 stories, the same height as ours. So we saw there was an opportunity here, said to the client, we think there's an opportunity to re-look at this. And we were very interested in looking at the overall context and composition of the city cluster. And we felt there was an appropriate to go taller and to be more of a transition between the 40-story One Leadenhall scheme and the 62-story 22 Bishopsgate. So I think Jeremy can possibly put his cursor on and just show the outline on the bottom right. You can see our scheme blue outline was what was consented, and the One Leadenhall scheme directly to the left there. So we made this approach to the city, and to look at improve the composition of our building by stretching it upwards, but also looking at how it looked within the cluster. So we added a significant area, but we also added 10 stories to the building. So, you know, made it more viable for our client. Next. So this shows the building in context. What we've looked to do is develop a series of terraces, accessible terraces up through the building. And you can see how the building's very open to the west with the conservation area and the constrained heights of the buildings there. Next. So the building sits right up to the northern boundary and fills the whole extent of the site. And what we also do, our building is quite interesting. Our title for our plan goes to the middle of the road, to the middle of Bishopsgate. So we developed this idea of cantilevering the blocks out. So you'll see now, if you go down on site, the temporary steelworks in and the first cantilevers just appearing. So it's quite a dynamic form. It's quite exciting as you move up through Bishopsgate with these stepping forms. Next. So in section, you can see how the building steps back, activity on each terrace. The northern core, there are two cores. The northern core sits right on the northern boundary and the southern core sits on the eastern boundary. And then the building opens up to the south and the west. Next. So the floor plates are ground floor on the left. You can see the northern core and then the southern core sitting directly on the boundaries. The footprints, we explore various options for the cores, but the footprints are quite tight. So you inevitably end up pushing them to the edge of the site. And then what we end up doing and what we've done is we've brought light into the lift lobbies as we go up through the height of the building. So we've got a double-decker lift system. So we have a double height entrance hall. It's access from both Leadenhall and Bishopsgate. We've got some retail that's configured around the southern edge. And then this double height space has mezzanine floors that pull back from the facade. So they appear to float within this space. They're linked with a glass bridge, and escalators get you up onto this mezzanine, which enables you to get to the upper car of the double decker. Next. Then as we move up through the height of the building, the overall floor plate steps back to the north. You can see the cantilevers stepping out over Bishopsgate, and you can see the terraces appear as we step up through. Next. And then through into the tower, the uppermost block. You see column-free space, great views to the south and the west. And then at the top of the building, we have a 3-story pavilion. And a key requirement for the planning and for the planners was to create a publicly accessible viewing space. And what we've done with the pavilion is created an amenity at that level, which also has a suite of meeting rooms within there as well. Next. So it's slightly unusual or slightly unlike a lot of city buildings, particularly in that area. It's quite a stripped back interior. We've exposed fair face concrete on the lift lobbies and then the staircases, and we've exposed all the steelwork up through the height of the building. And then using a simple palette of natural materials, a lot of timber and marble on the lift faces and terrazzo on the floors. This gives you a feeling of the entrance hall is very much a publicly accessible space. Controlled into the lifts is at the mouths of the lift lobbies, and the intention is to encourage people to come in and use this space. Next. And this gives you an idea of, as you move into the lift lobbies and the staircases, how the material of sort of self-finished, the palette of materials are self-finished materials, fair face concrete, timber, and colour brought in with things like flooring. Next. So on the office floor plates, we had a lot of debate with our client as to the level of stripped back nature to the building. As I say, all the steel work is exposed, as it presents its own challenges with the sort of painting of the intermescent paintwork, particularly on the sort of the connections. But the idea is the building is relatively stripped back, but we have within the soffits, surfaces are exposed, but we have a floating ceiling panel that sits between the steels and contains the surfaces, lighting, speakers, and the like. Next. So there's a whole program of amenity within the space. Starting at the top of the building, there's a suite of meeting rooms that we envisage will be hired out, or there will be events run within there. At level 26, broadly halfway up through the height of the building, we have a whole floor that's taken up with a restaurant, cafe, and bar, and that opens out onto a level 26 terrace. We have further terraces further down the buildings that are accessible to tenants on those levels. And then within the double height reception, we'll have lounges for meeting people, but also cafes and some retail at that level. And then within the basement, there's an extensive bicycle facility and showers in support of that. Next. Oh, sorry, one other item. What we've also installed is an auditorium at level 1. And this is a double height space with bleacher seating. So it's a flexible space for events. It will be primarily for tenants within the building, but also potential for events from outside, people using it from outside. Next. So just very quickly through the pavilion at the upper level, the meeting rooms all have demountable partitions. The whole space can be opened up. It's anticipated the viewing gallery will be used for events other than just public access, partly because there are so many tall viewing spaces within the city now, and a number that are taller than our own. So it's trying to create some flexibility for the client. As you can imagine, fantastic views from level 50. Next. And the idea is the meeting room suites at this level, next, can be opened up, and it can be a larger space for events and the like. Next. And then, as I said, the terraces, this is level 26 terrace, fantastic views out over the city. And this links to the restaurants. Next. And then extensive, nearly 1,000 bicycle storage spaces in the basement, which is at lower ground level, and then numerous showers and lockers to support this facility. So just some of the dynamics. This is from the from Bishopsgate, the view looking up, seeing the cantilevers stepping out over the street, double height reception. Next. And then the view looking up Bishopsgate. And on the right, the lower stone-clad building that responds to the junction and the stone buildings around the junction. Next. And then there we have a lighting strategy working with EQQ lighting that picks up the architecture and tries to deal with the architectural, the legibility of it at night as you see it during the day as well. Except, showing all the sort of cantilever blocks and picking out the main architectural elements. Next. And this is the view from the monument, seeing it in the context of the other tall buildings. Next. And then from St. Paul's, looking back at the eastern cluster. Next. So I'm going to hand over to Jeremy, who's going to talk about some of the engineering aspects.
Thanks very much, Ollie. I'd love to be in a room with you all tonight, but we're at home and hopefully we'll all be back together again soon. I'm going to talk a little bit from a personal perspective of why I think this is a special project. Structural engineers, of which I'm one, tend to get super excited about towers, but this has been a cracking building to be involved in, and I'm going to tell you a little bit about why I think that is. So there are two sort of principal points from me, the team and then some kind of neat innovations that have been embedded into the project. And then when the way the teams worked and those innovations have come together, we've had some really lovely conceptual coordination. It feels like a genuine collaboration that we've been chuffed to be involved in. When we look at the team a little bit, there was some clear principles, I think, that the team set that helped us develop the scheme. So we had some really good, clear goals. We were very keen on sharing the objectives. They were kind of jointly owned. Everybody strived to achieve them, not individuals kind of working for their own companies in that sense. It was very, very open collaboration, bouncing ideas around. Nothing was off the table. And early days, I'll share a slight story where Ollie was even willing to see the sketches from my 5- and 7-year-old at the time that they developed for the scheme and tolerate the ideas that they were happy to put forward for the development. So that gives you a flavour of the kind of the environment and the collaboration that was going on. And there was this sort of really nice culture of respect, recognition for ideas, keenness to allow people to put their stuff forward, and it was well considered and received by everybody. On the innovation front, the building, bear in mind this was conceived in 2013, there was a really strong focus on energy and use. There was a strong focus on a healthy building for occupants, and at that time a very strong effort around the material efficiency and low carbon approach. And some of those themes are a little bit more normal now, but when we were putting the ideas together, they were a little bit ahead of their time, I suppose. So a lot of that came together with the conceptual coordination, as I mentioned, and that was the kind of glue that bound us all together. So a little bit on the clear goals. We did set out the project was framed around the UN Sustainable Development Goals, and that gave us a good holistic concept. We weren't really doing sustainable box ticking. We were trying to make sure that we really understood the big picture of what we were up to and why we were doing things. In terms of the clear goals, we made sure that the presentations that everybody did focused on cost, material efficiency. We looked at program, person hours to construct things. We considered how we were addressing planning, enhancing sales, rental values, the program, the buildability. But all of the presentations, we tried to make sure we were kind of coming back to the goals that we'd set ourselves as a team. On top of that, there was a strong focus from Mitsubishi around program certainty, quality, refinement. But then some more subtle things. Can building elements achieve more than one thing? And have we challenged ourselves as a team? So there was some quite sort of hard objectives, but also some softer stuff in there as well. When it comes to the conceptual coordination, I'm going to talk about a few things. But for me, one of the first things that we did is that the team allowed material efficiency to start to inform the massing of the building. So if you look at the diagram on the left, effectively the blocks actually split themselves up quite nicely into quite close to sort of 12 by 9-ish sort of steel grid blocks. And that's a really good efficient starting point for the frame. So the massing started to react to that and build from it. We also had the idea that we were keen to make sure elements achieve more than one thing. And one of the early ideas with a stability system, we had a lower core and an upper core. But when you look at the core that goes all the way up the building, it's actually only 8 meters wide. And that is typically for a tall build, 50-story building, you might have a core which is 25-ish meters or so for the stability system. So what we did is we used the bracing in the middle block to link the two cores together, and that allowed us to really thin down the core of the upper building. And as Ollie mentioned in his presentation, that freed up a floor plate of circa 13 or so clear span with no columns in that space. Any sort of fatter core would have really impacted on the viability of those upper floors. We had this metric around gaining area and what we could do for that. And one of the interesting things about this scheme is the ownership boundary actually stepped out into the centre of Bishopsgate. So we looked at that ownership boundary. We had our concept for the bracing that linked the two cores together, and we actually came up with the idea that if we hung the building further out, gain the area over Bishopsgate, but actually used the brace frame that we already had and we needed for stability, we could essentially get that cantilever for free. So we ended up as a team gaining 79,000 square feet of net, but we maintained our steelwork tonnage at 92 kgs a metre squared. So we didn't do it through adding lots of carbon, lots of cost. We actually did it by trying to use something that we already had and we needed. One of the innovations in the ground that we were excited about, we started with a scheme with a sort of clay piled scheme where we had 89 piles. There's a lot of kind of risk in the ground on this site, lots of existing obstructions. And we kind of integrated some complex soil modeling with the structural scheme and basically designed a raft scheme for the lower and middle rise buildings. So up to 26 or so stories, effectively the building's held up on a raft, and then the tallest element of the building is held up on some deeper piles. But that design iteration took us from 89 to 28 piles, big program risk reduction, big cost saving. It was around £2.5 million. But really kind of helped the scheme with its sort of early viability. There was about 5,000 meters cubed of concrete that came out of the scheme through that design iteration. We've got this quite unusual and interesting bracing scheme that kind of it's random essentially, and as I've explained, it does a job. It links those two cores together. It holds up the cantilever. But it's not the kind of uniform bracing that you typically see in a kind of braced box building. So it's randomly generated. It's optimized through 21,000 iterations. They're not kind of forced iterations. You just let the computer play with iterations and see which ones come out as the most efficient. So it's quite a blunt instrument using complex analysis. But that was fun to play with, and we also did work. One of the optimizations was also around the views, making sure we kind of didn't put the bracing elements in places that would be perceived as kind of obtrusive. In terms of the embodied carbon on the superstructure, there were sort of two main principles. I talked earlier on about getting in this conceptually optimized grid, and that makes a huge difference right from the start. So you're starting from an efficient point of view. And then on top of that, every single piece of steel work on the building has been individually optimized for the load that it carries. Now, that's quite rare in that most buildings, people kind of bunch the steel work together and kind of size it based on the kind of the chunk of load that it's carrying, but maybe in categories. Maybe there's sort of 20 or so of them across the whole building, but we've done every single element on this building. And it's made a really, really big difference. So the chart on the right is courtesy of A-Linear. And it was an early prediction for the story height of the building, what kind of tonnage we might have for a benchmark building across London. And what it was predicting was around about 120 to 130 kgs a metre squared for a building of this kind of shape and height in the City of London based on the benchmarks. And through this kind of concept coordination and generosity of the architecture to actually flex to allow material efficiency to be part of the architectural solution and the optimization, we saved about 2,500 tons of steel. Our tonnage was at 92, and that works out as about 5,000 tons of CO2, or 500 times the average UK citizen's carbon footprint. So there's some sort of big headlines in there. Yes, steelworks carbon intensive, but we were always going to use steel for this scheme. And so what we did is we used it in the most efficient way that we could. A little bit on the air and the MEP systems. So we had this focus around a kind of healthy building for occupants and also kind of tenant flexibility. We were really keen that people were able to engage with their own MEP systems rather than kind of feel that they were in this box that they had no control over. So one view on sustainable and low energy use is actually giving people some transparency and control over their own space. What we did with the air systems is we've got on-floor plant, and then one of the first concept decisions was to draw air in from the cleaner side, not the street side of the building. And that most of that air is drawn in from higher levels. Some on some of the lower floors, it's drawn in within the kind of notch adjacent to the Leadenhall building. But essentially, we're bringing the air in from a cleaner side, and that makes an initial difference. We've got some filtration on the building. So typically a centralized ventilation system, you take out large particles. On Eight Bishopsgate, we've gone a little bit further. The scheme actually takes out some of the smaller particles as well, takes out dust and pollen and things like that. But because of the on-floor system, there's also an option for tenants to upgrade. Now, clearly, we didn't know about COVID when we were putting this scheme together, but actually the scheme has proved to be quite robust from a kind of tenant challenge point of view with respect to COVID, because they have that individual control and that ability to upgrade the filtering further. That's been a good attraction, and the kind of interest on air strategy has grown massively over the last few years. One of the things I really like in the scheme as a structural engineer, but in terms of the MEP, I really like the fact that we've got CO2 sensors within the space. So that those kind of varying size pink bubbles, they're a way of showing you that we can actually kind of flex the air within a floor, and you can pump it up when it's needed, and you can reduce it when it's not needed. So each individual floor has flexibility to kind of lever up and lever down the air systems, and that makes a difference for energy use. So there's some significant energy savings realized from that, but it also allows us to give people air where they need it and take it away where they don't need it. Just some numbers on the air system, but some of the upper floors are designed at 1 per 10 and the lower floors at 1 per 8 occupancy, but our base provision for the 1 per 8 is 14 litres per second per person, and that goes up to 18 litres per second per person for the upper floors, and that is again, that was quite unusual for a tower in 2013 when we were conceiving the concept. And it's now much more sort of the norm, I suppose, in terms of people's requirement for high fresh air provision. But it's also a conflict. Normally in a tower with a centralized system, it's quite hard to provide quite high air provision because you then lose all of that space in riser distribution. But because of the on-floor arrangement, we're able to give our tenants a little bit more flexibility with the air provision. There's also an ability to upgrade that air provision further if people are interested in that, up to 20 litres per second. A couple of little nuggets in terms of the energy system. So our facade system, the base provision with the CCF is energy efficient. It's obviously great for views as well, which is a big part of why people want to be in a tower. But we also have a blind system, which is an active blind system that effectively tracks the sun. It's not going up and down all the time, but a couple of times a day, the blind system is actually reacting to the sun path. And because of that, we managed to realize a 5% total cooling load saving on the building. So it just shows the difference by kind of by taking some of those marginal gains, but really making a benefit. We're always going to have blinds in the space, but actually going back to that first principle about trying to make things do two jobs. Well, actually, if we're going to have those blinds, then why not use them and take some energy efficiency from that? The other thing that we do is that we pinch some of the heat back from the cooling system, and we use that to power to do the heating when the building needs it. And around about 60% of our annual heat demand is met by recycled heat. When all of these things are added up, it does make a big difference to our overall energy performance. So we've ended up with an EPC A-rated tall building, which we're really chuffed with. We're really proud of. That it's a rare thing for a tall building in the city. We think it's the UK's tallest EPC A-rated building. It's circa 40% better than building regs, and it's BREEAM outstanding. So chuffed with the scheme, chuffed with its energy performance. Really pleased with some of the carbon stories. And then this image I quite like to share, and I know Ollie hinted at this image earlier on. But this is the best image that I find for sharing the kind of open nature of the team and the ability to test each other, to share ideas, and then the willingness to kind of implement them on the scheme. So we started out with a different form of a building, but we all bounced ideas around and came up with something that hopefully you'd agree fits the site, is a great contribution to the city. But it is also, there's a sense of sort of shared ownership. Like we all feel that we've had a chance to influence the outcome. So back to Ollie.
Thanks, Jeremy. So I thought it'd be quite interesting just to sort of show the process that we've gone through. These buildings take a long time. Client obviously, as you can see there, started putting the site together in 2011. The design team were appointed, as I said, following an architecture competition in 2013. We got to planning within 2 years, which is quite unusual and as fast as you could probably go with a scheme of this size. In fact, it was a little over a year. I think it was sort of 15 months. Stood down for a year after that, and then as we said, we went forward for another planning. So overall, and with completion due at the end of next year, 2022, there's a 9-year process that Jeremy and I have been involved with this, and the actual construction is only 3 years. So it takes a long time to get to where we have to go next. So as I said, and as David said, we're getting there. We're broadly on the north core up to half its height, up to 24 stories, and 51 stories is the overall height. The southern core goes up to 26 stories, and you'll see the brown steelwork there. That's the temporary steelwork with the beginning of the first cantilever. So it's quite an exciting position for us to reach and start trying to understand the impact it has in Townscape terms on the street. Next. And then this is a view that we picked up recently, just showing how the makeup of the site and how it's building up between particularly the Leadenhall building and 22 Bishopsgate. Okay, next please. So goal, as I said, practical completion end of 22. There's already quite a lot of activity. We have a marketing suite next door. There seems to be a lot of activity. So, you know, it's onwards and upwards, and hopefully progress will carry on as it's been going. Thank you very much.
Great, thanks very much, Oliver. Absolutely fantastic. 9 years. You look exactly the same as you did in your photos at the beginning of the presentation.
I looked old then.
I've got a few questions, which I think you can see, but I'll read them out, and then we can perhaps pick up any other points that come out of that. But do ask questions. Oh, there's one or two more just come in. So Richard Saxon's just asked about the proximity to 22 Bishopsgate. It's always worth asking that question. So what were the issues arising from that? He mentions kind of Wall Street tightness. I was walking around the cluster a couple of weeks ago, actually, but it has the buzz of a New York central area as well as the tightness. So it's a positive as well. But anyway, what's your...
So we are right on our northern boundary. This is what the previous scheme did. The size of the footplate of the Bishopsgate building determined that it was a side core building then. As it happens, we got consent prior to 22 Bishopsgate, and they had a tapering scheme, as you'll recognise from before, what was known as the Pinnacle. So arguably, they brought themselves closer to us, as it were. But the principle of replacing our previous scheme that sat on the boundary, that principle was established through the previous buildings. So it is close. They're broad, they're just over 3 meters away from us at their closest point, but they taper away, so they get angled views to the side, to the east and west from us.
Yeah, and your core's on that side.
Yes, and we have had a lot of discussion with them of the nature of our core. We didn't want to have a blank, dead core. So we have got openings in there. So you do see activity, you do see people moving, you do see light coming through it. So we're very keen where we could to animate that edge. You know, there's quite a difficulty in from fire terms to put glass on the edge there, and we have to have drenchers to deal with that. But it gives an animation to that edge of the building.
Another question, which is sort of putting it into an international perspective. Did you benchmark it against other tall buildings around the world? And what did you learn from that?
So we had an interesting process through the competition where we were on board before the engineering disciplines, and one of the what was very successful with Arup's bid is that they would offer the ability for their involvement from all their offices around the world. So what was very appealing to us as architects, but also to the client, was a combined MEP and structural offer, but also one that brought in the experience from their overseas offices.
So shall I chip in on that, Ollie?
Yeah.
So what we did on that was quite good. It was quite good fun, actually, and quite inspirational. But I actually employed some lead engineers from our Sydney office, from our Hong Kong office, from our Berlin office, from our LA office, and from our Hong Kong office. And I think they all got some fee. They all got a little bit of a fee as well, and they all had a go at the competition from their perspective, from what it would look like as an answer for them in the different parts of the world, and then we pulled that together, and we tried to kind of take the best of the best, as it were, some of the ideas that different people had around the globe, and bring them into the scheme. And it was very interesting how different regions approach things, but it was a nice open way of sharing the ideas around the firm.
The other aspect of sort of benchmarking that we brought on board was Lendlease, the construction managers, and we have used experience of theirs from and advisors from particularly on the buildability aspects of it from Australia and from North America. So we've been trying to use knowledge and experience where we can.
Actually, Jeremy, just as a general question, how does the sustainability goals here compare with some of the other big markets?
We're quite advanced in terms of some of our sustainable goals. I think it's probably fair to say that recently we've taken quite a lot from Australia in terms of design for performance and neighbours. And so I think if there are any Australians on the call, I think they might say that they've been ahead of the curve a little bit in terms of how buildings genuinely perform in terms of their operation. And that is becoming much stronger in the UK market now. In terms of embodied carbon, I think the UK and London market has probably been the strongest push of any nation in terms of embodied carbon. I did a presentation something like 7 years ago to our LA office, and I was talking about Chiswick Park, and we designed a new low carbon post-tension concrete mix there. And we played around with 30 different concrete mixes to try and save carbon, and the reality, the end result was we saved about 30% of the carbon through doing that. And at that time in the States, there was genuinely no interest or no kind of awareness of that as a topic. So I think it does kind of move around a little bit depending on where you are. But maybe the fairest way of answering the question is that we should all take the best bits from around the globe and bring them together, and then you get the best answers.
I suppose it's also where the activity is very intense. There's a lot of pressure a lot of R&D goes into those areas as well. So that's, yeah. My colleague Bradley Baker has asked a question about entrances. So how the ground floor plate works. And you have an occupier with a larger space. Is there the ability to carve out some space for a separate entrance?
Has he got someone in mind? Yes, we have. So we're keen not to split up the architectural concept is very much to have that as a sort of lively open space where people feel that they can, and particularly how that's a sort of insurance market and how people meet in and around locally, around Leadenhall Market and the like. But there is the ability to screen off from Leadenhall to the southern core and to be able to access the lower levels to someone who takes a sizable chunk.
Yeah, okay.
Architecturally, we like the idea it's a free-flowing space.
I get that. And you have to do what you have to do.
Yes, of course. Yeah, but it's something we've tested, yes.
Yeah.
And people have come forwards asking the question as well.
Yeah. It's the way of things today. Ken Shuttleworth's asking some questions. The amount of glazing. So do you think the energy, given the model you've been working on, if you changed the solid to glass ratio, could you have improved further?
We don't think so. The CCF facade is very efficient. It's a system that basically is two skins of glass that are sealed that have a positive, very low pressure applied to them. The blind is an integral part within that, as Jeremy talked about, dealing with glare. And we have done a lot of analysis on other buildings looking to put more solidity in. But what we've found is that a CCF system, for what you gain in the light levels and the like, is as efficient as we can get.
I think I'll chip in on a couple of bits. The other thing that's happening is that there's more interest in embodied carbon in facades as well now than there was. And actually, we've done some studies to show we ended up at a fairly good place with our system that we chose. I think the active nature of the performance is really important. And I think if you're going to go with a CCF, then in my view, the active blinds do make a really big difference. And I mean, sometimes you can get lost in the numbers, but 5% drop in cooling load for the building because of those blinds is quite a big deal on an already efficient system. So I think, Ken, we think it's quite a good sweet spot between daylight and energy performance, but also with a recognition that people do like views out of tall buildings as well. So I think it's a nice sweet spot as far as we're concerned. I think there was a second part of Ken's question, wasn't there, to do with COVID? And we have actually had to try and answer that question. And whilst we didn't know, so the second part of the question was, would we have done anything differently had we known about COVID? And we have done one change to the building since COVID came to light, which is effectively to change the fresh air provision to the toilets. So within the building, a fairly standard approach in most commercial buildings was to actually allow the air to drift from the floor plate space, and you kind of use that as your makeup air in the toilets. But now that we've actually shifted the system so that actually the air is effectively fresh air in the toilets as well as it is on the office floor plate. And I did go on a little bit about the air in the presentation, but hopefully you could see from the way that we set the system up with the ability to have, it's already got filters on the system, but that tenant control and that ability to upgrade further, combined with some fairly generous fresh air rates for a tall building, we've found that it's been kind of very well received in the market for COVID, even though we had no idea about COVID when we put it together. So one change, Ken.
Yeah, good. So just looking at the questions, we'll come back to John in a minute, but Robin's made a question, actually. It's Robin Brody Cooper, which I really liked that interior shot you had, actually, of the the way the ceilings are working in the structure. So he was asking, would you, a more radical question, would you consider getting rid of raised floors and getting some extra floors?
We did look at that, but at the end of the day, there's a very strong pressure to keep the raised floors. We challenged whether we could tighten them down, but I think it's something on other projects we will look at increasingly.
Did you look at displacement, just out of interest?
We didn't, no. I mean, we would have considered it and looked at the merits of it, but with a client, steered by the likes of Stanhope, in some areas that you don't throw everything up in the air.
I think I would major on the importance of not trying to move vast amounts of air around in a tall building because of the inefficiency that brings from both an energy point of view and a kind of space efficiency point of view. So I think the having the on-floor plant and drawing that air in locally does allow us to be more generous with our air, but not give away the kind of the space to kind of large risers, and also lose the energy efficiency from moving all of that air around on a taller building. So I think for the shape of building we had, I think I quite like the air solution that we've got.
Yeah. Okay. Just on some planning points, actually.
I think we've missed one question there from John at 7.
Yes, I was going to come back to that. So John,
sorry. Okay.
Rogers, Stoke Harbour, was sitting next door. Probably now. Will he still be able to see some pools from level 14 in Leadenhall?
I'm afraid he.
Yeah. It's probably already gone, hasn't it?
It has, yes. Unfortunately, I'm afraid the nature of the changing city, views aren't preserved, and as Ken will be aware, we thought we had a good view to the south that has been partly impacted by Ken's building.
Yes, so
as we have on 22 Bishopsgate.
Yeah.
And actually, it was quite a compelling discussion to take to the city. So the city having consented our scheme at 40 stories and insisted on a public viewing gallery at the upper level, subsequently consenting one Leadenhall, we had a public viewing gallery that had a very fine view of Ken's building plant at the top of the building. And we couldn't see the river, and so we did try and suggest to the city that maybe a public viewing gallery that couldn't see the river to the south was possibly better if it was a bit taller.
Well, I seem to remember the presentation at 8 Finsbury Circus, when the last City Architecture Forum event we did, which was a proper tour of a building, a nice building in Finsbury Circus. And we had a debate in that. I think Ken might have been there actually.
He was, I remember.
He said, why don't you just go higher? That was the point. And I'm sure we can take the City Architecture Forum can take full credit for the decision to go up further. Probably had more to do with the way the cluster had developed, but it was, I remember that very well actually. I think we've just about run out of questions. So I think if I just sort of conclude, I think I'd like to just thank both of you. It's really exciting to see the nature of this sort of building coming through at the moment. And actually, as you say, with a lot of foresight in the specification, which has made your lives slightly easier, I suspect, than it would have been otherwise in the current situation. And we look forward to doing our City Architecture Forum tour in beginning of 23, probably, based on your program that you just saw. And a couple of things I did pick up from Jeremy's presentation. I thought your "let the computer play" comment about how you design the structure was quite fun, actually.
The computer's cleverer than me, David.
This is what we suspected about structural engineers. That's all you do is just press a button.
He did do that. And then the damn architect came along and said, well, actually, I'd like to move that diagonal because we want to get the pattern looking right.
But then Jeremy retaliated by getting his children to redesign it for you. So
it had a little bit of tinkering.
Okay. So I think I'll probably wrap it up there and say thanks to you guys for everything tonight. Just from the City Architecture Forum's point of view, for those who I hope you are getting the emails, because you probably are, because you're here tonight. We've got 2 more events coming up, 29th of April, entitled "The Future of Work is Not Ours," which is a great title actually, which actually is a London Society event that we're co-promoting with them. And on the 12th of May, Thermal Comfort, Revealing the City. So again, it's an environmental initiative which we're doing a special event for. So there's some interesting technical stuff coming, and no doubt I know there's a number of other building presentations in the pipeline going forward for the rest of this year. So, and hopefully some of them will be in person, but they work pretty well on the screen as well, I have to say. We've had a great turnout for these over the last year. Okay, so I just want to say thanks very much for everybody. Thanks to Jeremy and Oliver, and good night, everyone.